guys, and welcome to Algebra class today. Today we're looking at lesson 7.8. We're factoring some more polynomials. So we're going to review some strategies that you've already learned, and we're going to learn a new strategy for grouping. So the first thing you're always going to think of when you factor polynomials is the greatest common factor. So here's our first example. We have 3x cubed plus 6x squared minus 18x. So Ben, do you see a greatest common factor in this trinomial?
Wouldn't the greatest common factor be 3x?
Fabulous. Good answer. So you have 3x, and if we were to factor that out of the first term, what would you be left with?
You would be left with x squared.
Plus
6x.
Well, we factored out 3, so we're left with, you're good, we're left with 2x. And in this term, we have minus 6, right?
6.
So the quick double check is just, does this times this give me this? And we're always doing those quick double checks. And so, awesome. All right, so Ben, can you factor x squared plus 2x minus 6x?
No, you can't.
You're right! It's not factorable. If you try out all the possible combinations, you'll find that there's no way you can factor it down even further. So that's where you stop. You factored out the greatest common factor, and you are good. Now for this next one, let's go through our list. Is there a greatest common factor you could factor out?
Yeah, it's 4a squared.
Awesome. So we're going to take that out front, 4a squared. And for the first term, what would we be left with?
9a squared.
Good. And we factored a 4a squared out, so we're just left with a 1 here.
Yeah.
Now, you guys may remember our special rules for dealing with the sum and with the difference of squares. So this one, first we're going to notice that our coefficient out front is a perfect square. This is a perfect square, and there's a subtraction sign in the middle. So we can instantly remember that pattern and factor it as 3a minus 1 and 3a plus 1. Okay? So that only works if you have perfect squares there. Hi guys, and welcome to part 2 of factoring and grouping. Today we're going to continue on factoring some more things and going through our list of what we have here. So Ben, every time you look at factoring something, what's the first thing that you think of?
I think of the greatest common factor and what it is.
Yeah, so here the greatest common factor is 3r cubed, right?
Yeah.
So when you factor that out of each term, we're left with r squared plus r minus 30. Okay, so can you factor this down?
Yes, I think you can.
Yes, you think you can. So the first thing we're going to look at is this middle term, okay?
Okay.
Can we break this into factors that when added together would give us this middle term? So I'm thinking 30 can be broken into like negative 6 and positive 5, right?
Yeah.
Or it can be broken into positive 6 and negative 5.
Yep.
So if we add this together, we end up with a negative 1. But if we add this together, we end up with a
positive 1.
Awesome. So these are going to be our factors. So we're going to go r plus 6 and r minus 5. Great. So we have factored the polynomial completely. Now, for some of your questions today, you're also going to have to solve the equation. So when it says solve the equation, it means you need to set each of these parts equal to 0, okay? Like we did in our last assignment. And we'll get to that coming up in just a second. All right, so here we are. We're going to factor it completely. So we're looking at each of the different sections of this polynomial, and we've factored it out. So we're going to set each part equal to 0. So 3r cubed set equal to 0. R has to be what?
I don't know.
Anything times 0 will give you 0, right?
Yeah, so it'd be 0.
Yep, so r has to be 0. Now for r plus 6 equals 0, what would r be?
R would be negative 6.
Awesome. And for r minus 5 equals 0, what is r?
R would be 5, right?
Awesome. And you do that quick check. You plug that back in there. 5 minus 5 gives you 0. So we're golden.
Yeah.
All right. So now we get to the fun part. We're going to factor by grouping. And this is the strategy you use when you've tried all the other 3 and nothing is working. Okay? So Let's look at this. Do you see a greatest common factor you could factor out?
No, I don't.
Do you see any squares in here?
No.
Do you see any products?
No.
No, because it has 4 terms. We couldn't do our traditional factoring of trinomials without some other strategies. So what we're going to do is we're going to actually look at this in parts and see if there is something, some sum that we could factor out of these. So if we take this and just look at it by itself, do you see anything that we could factor out of this, Ben?
I think we could factor out x, right?
Sure, we can factor out x, right? So then we would get x squared plus 3. Okay.
Yep.
Okay, I had forgotten to write something. This is supposed to be 3x squared, okay? So if we factor out an x, we're left with x squared plus 3x. And then do we have a common factor that we could factor out of this?
Yeah, you could factor out 2.
You could. So you could have 2 times x plus 3. Okay, now if we look at this, can we actually factor something else out now that I caught my mistake?
Yeah, couldn't you factor out x again?
You could. So we could actually factor out an x squared, and then we would just have x plus 3. Okay, now this is where you have to think distributive property, okay? So we have x plus 3 and we have x plus 3. Okay, so we can actually say we have x squared plus 2, x squared plus 2 times x plus 3. And the reason we can do that is that if you were to use the distributive property, you'd have 2 times x plus 3, and you'd have x squared times x plus 3, which is exactly what we had up here. So you see how we can actually use grouping to rewrite the equation. Cool, huh?
Yeah.
All right, guys, as we look at factoring by grouping, you're really going to be utilizing structure here. So you're going to look at the structure of the problem to help you find the answer. So here, as we look at this one, we're going to think, all right, is there anything in common about these two things? And as I look here, I look at, boy, this almost looks like if we were to factor out a 2, we'd end up with 1 plus 4 or something. And if we were to factor out a 3, we'd end up with, or a negative 3, we'd end up with 1 plus 4. So let's see if I wrote this problem correctly and see what we can do. All right, so for this first part, let's factor out a 2a, okay? And we're left with a plus 4b. Okay, so this isn't looking great yet, but let's see what we can do. Now, if we factor out a negative 3 from this, we would end up with a plus 4b. Hey, this is what we're after. We want what we have in parentheses here to be the same, because when that is the same, then we can use the distributive property to say it's 2a minus 3 times a plus 4b. Hooray! So we just factored this by grouping. Okay, now we're going to look at one that this is actually number 28 from the book, and it says solve the equation, which means you're going to need to factor it and then set each part equal to 0 to actually find out where this is going to cross your x-axis. So let's go ahead and rewrite this so that we have everything over on one side of the equation. So we have 4 terms, and that's our first clue that we are going to have to factor this by grouping. So as I look at this, I'm looking for any kind of structure that tells me that this is similar. So here we have 4 minus 7, and I'm noticing that this has 4 and 7 in it if we take a 4 out. So let's factor that 4 out. And out of this one, let's factor out our y squared. So we're going to end up with y squared. So we're going to end up with y squared times 4y minus 7. And then if we factor out a negative 4 here, we're going to end up with our 4y minus 7. So we use structure to find those 2 factors that were the same. And when we rewrite it with a distributive property, we're going to have y squared minus 4, which is right there, times this quantity that was repeated, 4y minus 7 equals 0. Now, the ticket here is that we are going to need to set each of these equal to 0. Okay, so we've set each of them equal to 0. Now as we solve this one, we're going to add 4 to each side, and y squared equals 4. Now you're going to remember that y can be positive 2 or y, oops, you can't see that, y can be positive or negative 2, okay, in order to give us that y squared. And here we're going to add 7 to each side, and 4y equals 7. Divide each side by 4. And our y equals 7/4, and we are done. So remember, use structure, try and try again, and watch the Khan Academy videos. They have some great helpful tips on this too.